Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. The mathematics of music is a fascinating field that explores the relationship between sound, harmonics, and frequencies. Understanding these concepts can provide insights into how music works and why certain combinations of notes and chords are pleasing to our ears. Here's an overview of the key mathematical concepts involved. Sound waves and frequency. Sound is created by the vibration of an object, such as a guitar string or a vocal cord. These vibrations produce waves of pressure variations in the air. The frequency of a sound wave determines its pitch. Higher frequencies correspond to higher pitches, while lower frequencies correspond to lower pitches. The unit of frequency is the hertz, Hz, which represents the number of cycles or vibrations per second. For example, the A4 note on a piano typically vibrates at 440 Hz. Harmonics and overtones. When an object vibrates, it often produces not just one pure tone but a combination of multiple frequencies. These are called harmonics or overtones. The fundamental frequency is the lowest frequency produced, and it determines the pitch of the sound. Harmonics are integer multiples of the fundamental frequency. For example, if the fundamental frequency is 440 Hz, the second harmonic is 880 Hz, the third is 1320 Hz, and so on. The harmonic series. The harmonic series is a mathematical representation of the harmonics generated by a vibrating string or column of air. It consists of the fundamental frequency and all its integer multiples. The ratios of these frequencies create musical intervals, such as octaves, 2:1, fifths, 3:2, and fourths, 4:3, which are the building blocks of musical harmony. Consonance and dissonance. The relationship between the frequencies of two or more notes determines their consonance or dissonance. Consonance occurs when the frequencies have simple integer ratios, like 2:1, octave, or 3:2, fifth. Dissonance occurs when the ratios are more complex, such as 17/16 or 45:32. Tuning systems. Different cultures and historical periods have used various tuning systems to divide the octave into smaller intervals. Common tuning systems include equal temperament, used in modern Western music, and just intonation. Equal temperament divides the octave into 12 equal parts, which allows for easier modulation between different keys but sacrifices some of the pure harmonies found in just intonation. Fourier analysis. Fourier analysis is a mathematical technique that allows us to decompose complex waveforms into their constituent frequencies. This analysis is fundamental to understanding the harmonic content of musical sounds. Mathematical music theory. Music theory often employs mathematical concepts to describe and analyze musical structures. This includes chord progressions, scales, and formal musical notation. Understanding the mathematics of music can enhance your appreciation of the art and help musicians and composers create harmonious and expressive music. It's a bridge between the abstract world of mathematics and the beauty of music. One of the most important mathematical concepts in music is that of harmonics. Harmonics are the overtones that are produced when a note is played. They are integer multiples of the fundamental frequency of the note. The fundamental frequency is the lowest frequency that is produced by the vibrating object, such as a string or air column. The higher harmonics are softer than the fundamental frequency, but they still contribute to the overall sound of the note. The harmonic series is the sequence of all the harmonics of a note, starting with the fundamental frequency. The first few harmonics of a note are usually the most prominent, but all of the harmonics contribute to the timbre of the note. Timbre is the quality of a sound that distinguishes it from other sounds of the same pitch and intensity. The frequencies of the harmonics of a note are related to each other by simple ratios. For example, the second harmonic is twice the frequency of the fundamental frequency. The third harmonic is 3 times the frequency of the fundamental frequency, and so on. These simple ratios are the basis for the consonance and dissonance of musical intervals. Consonant intervals are those that sound pleasant and harmonious. Dissonant intervals are those that sound harsh and discordant. In general, consonant intervals are those whose frequencies have simple ratios to each other. For example, the octave is a consonant interval because the second harmonic of a note is twice the frequency of the fundamental frequency. Dissonant intervals are those whose frequencies have complex ratios to each other. For example, the tritone is a dissonant interval because the frequencies of the two notes are in the ratio of 45 to 32. The mathematics of harmonics and frequencies can be used to explain many different aspects of music, such as the tuning of instruments, the construction of chords, and the perception of pitch and harmony. Here are some examples of how the mathematics of harmonics and frequencies is used in music. Tuning instruments. The most common tuning system in Western music is equal temperament. In equal temperament, the octave is divided into 12 equal semitones. Each semitone is a ratio of 12 square root 2 to 1. This ratio is used to tune all of the notes on a piano. For example, constructing chords. A chord is a group of 3 or more notes played simultaneously. The most common type of chord is the triad. A triad is constructed by stacking thirds on top of each other. A third is an interval whose frequencies have a ratio of 5 to 4. Perception of pitch and harmony. Our brains use the frequencies of the harmonics of a note to determine its pitch. We also use the frequencies of the harmonics of different notes to determine whether they sound consonant or dissonant. The mathematics of harmonics and frequencies is a complex and fascinating topic. It is essential for understanding the science of music and for creating and appreciating music. Dear friend, I hope you benefited from the video. Thank you for watching today's video. If you enjoy content like this, please don't forget to subscribe to my channel and click on the notification bell to stay updated with new videos. Also, if you liked it, be sure to leave a like and share your thoughts in the comments. Looking forward to seeing you again with new videos. I can't wait to bring you more knowledge from the enchanting world of science.